and good afternoon. I'm Florent Blangy from Créocéan, from France, and I will present a short overview of our use of CMEMS products for physical oceanography studies. I will say a few things that have already been said, but maybe in some more basic way. And so I hope that will be interesting, at least for the beginners users. Okay. My presentation will be organized in 4 parts. The first part is a presentation of Créocéan. The second one will be a short description of the Mediterranean forecasting system that we use for our Mediterranean studies. Third part will be a short presentation of an example of statistical analysis of CMEMS products. And the last one will deal with dynamical downscaling of CMEMS products. Créocéan is a company of consultancy and service in oceanography who belongs to the Keran Group. There are 61 employees working for Créocéan in 14 agencies worldwide. So I don't know if you can see, but the blue points are Créocéan agencies and the brown points are Keran agencies. 8 of the Créocéan agencies are in France, including the Caribbean and Pacific agencies, and 2 of them are in the Mediterranean coast, in Toulon and Montpellier. Créocéan has a wide range of expertise, which includes physical oceanography and modeling, seabed characterization, and environmental studies. These are a few studies or projects conducted by Créocéan the last couple of years. I'm not going to enter into detail here, but you can meet me or Michel Collinet with the director of offshore project in the icebreaker or later on. You can also refer to our website, creocean.com. The Mediterranean forecasting system supplied by the nucleus for European modeling of the ocean is the model from the CMEMS that we use for Mediterranean studies and that you have heard since this morning. The resolution of the MF8 is quite sharp compared to the global ocean products that we also use. The reanalysis covers 27 years, which make the statistical analysis of the products quite consistent. And hourly means are also available, which is obviously essential if you want to analyze the diurnal variations. And quite interesting also for dynamical downscaling. For example, if you want to simulate a storm that lasts for a few hours. The question have been already asked this morning. The period I've mentioned here are the period I've seen last week on the website, and the hourly means were only available for something like a month. It would be quite interesting for us to have a much larger period, but I suppose it represents quite a large amount of data. This slide represents some visual illustration of the MFS in the Ligurian Sea. This is a near real-time sea surface temperature. Here, the surface current, you can appreciate the 1/16th of a degree resolution. And you can have also some time series. Here you can see the hourly resolution and vertical profiles. In the last profile, you can actually appreciate the vertical discretization. And I made these with MATLAB, but actually you can obtain them directly from the CMEMS website. And we have currently one study in progress at Créocéan with the MFS. Unfortunately, it is too early for us to present some results. Therefore, I will show you some results from another study in which we have used some product from the global ocean region, the Mercator Global Ocean product. This side represents a rose current and a correlogram of surface current at some specific node of the Mercator Global Ocean model in the Caribbean. Both types of illustration are used to show the statistical distribution of currents in terms of magnitude and direction. In this example, you can notice the prevalence of northwestward currents and southeastward surface currents with quite similar rates of occurrence and magnitude of currents. I believe that this type of bicycle statistical illustration could be useful for the users if they were available, maybe not directly on the Copernicus Marine Service, but through some kind of open access tool. This slide represents some analysis of surface current flows. In the specific case, we use the current flows to illustrate the influence of the seasonal variation of trade winds on the seasonal variation of surface currents. Also, in this case, it would have been interesting for the consistency of the statistical analysis to have a longer coverage period than 2 years and a half. That's not a Mediterranean problem, that's more for the global ocean products. I know that there are some global ocean multi-years products available in the CMEMS, but the spatial resolution of this product, which is of 1/4 of a degree, is not enough in this kind of region. This slide just represents some vertical profile of salinity and temperature by months obtained from the Mercator Global Ocean database. We use this kind of illustration to show the seasonality of the stratification in the area of interest. And that was the temperature, and now the salinity. Okay, this is the last part of my presentation, which deals with dynamical downscaling. So what is dynamical downscaling? I think that you know what is it now. It is a method to obtain a high-resolution local model from lower resolution model outputs at initial and boundary conditions. Why is it so interesting? Because it enables to refine as desired the resolution, whereas the CMEMS products have regular grids. So here you have an example of finite element mesh made with mic, and the resolution is of about 5 kilometers offshore and only 20 meters in the area of interest. And you can also couple the model with other modules. Some of them requires a very high resolution, such as mud and sand transport, dispersion model, Ecolab, oil spill, particle tracking, etc. And you can also add tides and wave to the model. As far as I know, the CMEMS product does not take them into account so far. But I think it is one of the main mid to long term evolution of the service. This slide represents some result of downscaling obtained with the kind cooperation and assistance of Andra from the HI Italia. And the first map is a Mercator global ocean surface currents. And the second map is a Mike surface currents result after 48 hours of simulation. So you can notice in the second map that the Mike surface current have adapted to the local bathymetry, especially in the northeast coast of Cuba. This slide presents some comparison between Mercator Global Ocean in red, I don't know if you can see them, and in blue, this is Mike. And this is the vertical profile of salinity, and this one is vertical profile of temperature. So you can see that there is a very low drift of Mike model compared to the Mercator Global Ocean model during the 15 days of simulation. And here are the temporal, the time series, and you can see that the temporal resolution of the Mike model, which is in this case of 6 hours, enabled the simulation of diurnal variation, especially in the third graph, which is the temperature. Thank you for your attention. Please be free to ask any question or meet us during the coffee break.